And the quick review for wind current motion problems. All right, so we're going to solve these with a system of equations, and I'm going to try to do a quick review. We'll see. All right, Bob canoes upriver for 6 hours and goes 12 miles. The next day he goes downriver in 2 hours and stops 2 miles before he started the day before. What is the speed of the current? All right, so you have to look at this problem and say, oh, this is a current wind problem. So with that current wind problem, remember we're going to get started with the formula. Rate times time equals distance. Rate times time equals distance. We're going to have a little bit different chart though. We're still going to have a rate column, time column, distance column, but our rate column is a little bit wider. And don't forget in this, we got to deal with against the current and with the current, or with and against. I labeled it that way because I always like to go in order. All right, don't forget to name your variable. All right, so what are we dealing with this problem? Bob canoes, so we're canoeing. We're canoeing. So this is the canoe speed, is x, and that would be in still water with no current. Then the other is the current speed, and that's y. Okay, so your rate column is always this. When you're with the current, it helps you, and you add the 2. When you're against the current, it hurts you, and you subtract the 2. So this is going to be x minus y. The current's hurting me against the current. This is going to be x plus y. It's with me. And by the way, in case you didn't know this, going up the river is always against the current. Going down the river is always with. So if you didn't know that, now you do. Okay, let's see what else we can fill in for our chart. Well, it says Bob canoes upriver 6 hours times 6 and goes 12 miles. Cool. Distance 12 miles. And then if you look, it says the next day he goes downriver in 2 hours, time 2 hours. Now be careful here. He stops 2 miles before he started. So he went 12 miles the day before. He stopped 2 miles short. So that would be 10. All right, you got to think a little. All right, what students like about these are the equations are the rows. So here's one equation. And don't forget, we're going to need a parentheses here, right? And here's the second equation right here. Okay, so I'm going to distribute as I write the equation. So this ends up being 6x minus 6y equals 12. And this one ends up being 2x plus 2y equals 10. Now I have to decide, am I going to solve this by a system of equations with, am I going to solve this by substitution or elimination? And I'm going to choose elimination. Okay, substitution will work as well, but I'm going to go elimination, and I'm going to eliminate my y's. So let's see, actually all I need to do is multiply this black equation by 3. My new black is going to be 6x plus 6y. See, I got my y's to be equal, and opposite equals 30. Be careful, make sure you distribute. Okay, so now I'm going to add up the blue and the black. I'm going to get 12x equals 42. And I'm going to divide the 42 by 12. Take my calculator. 42 divided by 12 equals, and I get 3.5. And x equals 3.5. Now, what in the world is x? Well, see, I named the variable. X is the canoe speed. Therefore, I'm dealing with miles and I'm dealing with hours. So the canoe speed is 3.5 miles per hour. But be careful. They wanted the current speed. So now I have to choose one of the equations and solve for the current. I'm actually going to come back and use this black. 2x plus 2y equals 10. Sub in my 3.5, right? Sub that in for the x. And I get 7 plus 2y equals 10. Add a negative 7 to both sides. And 2y equals 3. Divide both sides by 2. And I get y equals 1.5 miles per hour. And that's the answer to the question, is the current speed. All right? So wind current. Actually, most students think they're easier as long as you remember to make the object, the canoe, the boat, the bike, the X, and the wind or the current, the Y. Set up your rate column the correct way, and away you go.